Okay, as I think you can see by the title of the video, we're going to talk about rules of exponents. It is part one. There will be more to this. There are quite a few rules that we'll go over during Unit 2. But this takes over the vast majority of them. It also introduces you to some new vocabulary. Before we get to the new vocabulary, we got to get to some old stuff. Just want to make sure some basics are understood by everybody. We know that multiplication is a shortcut for addition. If I have 3 plus 3 plus 3 plus 3, instead of saying 3 plus 3 plus 3 plus 3, I just say 3 times 4. Exponents work in a very similar way. They are a shortcut for multiplication. Where multiplication shows repeated addition, exponents show repeated multiplication. And that's something we should have in our background knowledge. That's something we've talked about in the past. Just the idea that if I have something like 3 to the 4th, that means I have 3 times itself 4 times. That's the idea of exponents. A quick vocabulary check as you jot this down. You should already know where I'm going with this and what these different terms would be. When I look at x, when I have any letter or any symbol representing an unknown number, I know that that would be the variable. When I look over at the green 5, I notice that that is the number directly in front of a variable, and that would make that the coefficient. And finally, the big topic of the day, the red 3 would be an exponent or a power. So just a quick recap on some vocabulary that, again, should be background knowledge. Some new vocabulary for you, however, would be a monomial. A monomial, mono meaning one, is a constant variable or product of the two. Constant variable or product of the two with non-negative integer exponents. There are no negative exponents involved if this is going to be a monomial. You're looking for a constant like 5, a variable like x, or a product of the two. We might also have exponents like 2 for a power of 2, but as long as it's not a negative exponent, we still have a monomial. You're basically looking for a term of one term, no addition or subtraction involved. Each of those would be examples of monomials. One big thing to look out for, if you have division by a variable, that is not a monomial. Meaning if I had something like x over 5, x divided by 5, that still qualifies as a monomial. That's good. However, if I had 5 divided by x, since I'm dividing by a variable, that does not work, and that is not a monomial. So a quick checkup to see if we understand this idea of monomial. We're looking for one term, a constant, a variable, or a product of the two. For example, I have 10. That is a constant. That is just one constant. Yes, you better believe that that is a monomial. Next term we see is f plus 24. Notice, if I looked at just f or just 24, I might have some monomials. But when I have f plus 24, I have two terms, and that would not be a monomial. H squared, that is a variable with a power that is non-negative, and therefore that would qualify as a monomial. And then the last one that we see there, 10x divided by y, because we are dividing by y, that cannot work, and that is not a monomial. So just the new vocabulary to get down and be prepared for. Now we're actually going to talk about some rules of exponents. Now this is the one that is in your wheelhouse that you have seen here before. I have x to the third times x to the fifth. When I think about that, I have x to the third, which would be x times x times x. I'm multiplying that times x to the fifth, which would actually be 5x's. And so now notice I have 3x's and I have 5x's. If I was going to simplify this, I would say I really have 8x's. And that's the simplest rule that we have for multiplying exponents and simplifying exponents. To multiply two powers having the same base, and please do not skip over that concept. They must have the same base in order for this to work. When they have the same base, you can add the exponents and leave the base the same. The base stays the same and we add the exponents. Using algebra, you have a to the m times a to the n. The base is a, the base stays the same, and then we add the exponents. Base stays the same, add the exponents when multiplying. Let's get to some examples. B to the 7th times b to the 4th. Notice you have the same base, which would be b. That means the base stays the same, and I can add the exponents, which gives us just b to the 11th. And again, I think that's as simple as it gets, and that's in your background knowledge. Notice in the box a couple things you might want to jot down in your notes as you're watching this video. Order doesn't matter when multiplying. We know that 2 times 3 is the same thing as 3 times 2, and so we might use that to help us simplify here. We're going to multiply the coefficients and then add the exponents. For example, here I have 3n squared times 4n cubed. Notice the base here is n. 3 and 4 are just coefficients. To simplify this, I'll take the coefficients out in front. Then I have n squared times n cubed. This gives us a total of, well, 3 times 4 is 12. Same base, add the exponents, 12n to the 5th. A little bit more difficult example because of the negative, but again, the same idea. I have a negative 2 times 5, which gives me a negative 10. Then I have to take care of like bases. So notice, I'm only going to deal with the x's. The exponent here would be a 3. The exponent that is not written but understood there would be a 1. So notice I have x to the third times x to the first. That gives us x to the fourth. And then I have y squared and y to the fourth, which gives us y to the sixth. One last example. You might want to star this in your notes as you're watching this video. I love to put this type of question on a quiz. I love to trick people up. Remember the rule. The base stays the same, and we add the exponents. In this case, the base is 2. And so every time the base stays the same, 2 stays the same. Now I will add those exponents. So I will have x plus 3 plus 5. But knowing your rules of algebra, we know we can simplify that power up there. I have x plus 3 plus 5. I really have 2 to the 2x plus 8. I would definitely star that example. That is a great quiz question that Mr. Bartlett would love to throw at you. So that takes care of the first rule. If we're multiplying, we keep the base the same and we add the exponents. Let's take it to another level, though. What if I have a power to a power? What if I have x to the fifth to the third? What does that mean? Well, to me, I'm thinking x to the fifth to the third really means x to the fifth times x to the fifth times x to the fifth. That means our base would stay the same, and we would add the exponents, 5 plus 5 plus 5. But notice there's that idea of what's a shortcut for addition? If we have 5 plus 5 plus 5, we really have x to the 5 times 3, which is x to the 15th. That takes us to our next rule of exponents. When taking an exponent to another power, we call this a power to a power property. The power to a power property says instead of adding the exponents, we're going to multiply them. So notice if we had a to the m and we took that to the n power, we would multiply those exponents. And again, notice the base stays the same. Quickly to an example. If I have u to the fourth to the fifth, if I needed to expand that out, that would be u to the fourth times u to the fourth times u to the fourth times u to the fourth. And you see why we don't necessarily want to have to expand this out every time. Notice I actually have 5 4s. When I add that up, I could take a shortcut and I could multiply those two, and that would be u to the 20th. An example to absolutely star in your notes here. Now we have 2x cubed. Think about this when I expand it out. I would have 2x times 2x times 2x. To simplify that, I could think of this as 2 times 2 times 2 times x times x times x. What I want you to notice there is then really I am taking 2 and I am cubing it, and I am taking x and I am cubing it. So as a shortcut, we have our last rule here for today. If I have something in parentheses, this would be a power of a product property, the power of a product. Whatever's inside those parentheses, we're going to take each of those values to the power. In this case, we take a to the n and b to the n. Our answer up here for 2x cubed would be 8x cubed. We've cubed 2 and we've cubed x. A couple examples to help you with that idea of a power to a power. Notice we have negative 2x in parentheses to the fifth. To tackle this problem, I want to think of negative 2 to the fifth times x to the fifth. I think the x to the fifth part's pretty straightforward. X to the fifth is x to the fifth. Negative 2 to the fifth, notice we have a negative number to an odd exponent. We know our answer should be negative, and 2 to the fifth is 32, so we have negative 32x to the fifth. A more difficult example that kind of ties all our rules together. Remember back to your order of operations and your PEMDAS concepts, we have to take care of exponents before we can multiply. Therefore, I got to take care of the exponents on each of these. That would mean I have 3 to the third and x squared to the third times 2 to the fourth and y to the third to the fourth. Lots of stuff to take care of here. Please notice the work that I am showing. 3 times 3 times 3 is 27. And I have x squared to the third. X squared to the third. Remember, a power to a power, we would multiply those exponents. Then I have 2 to the fourth, which would be 16. 2 times 2 times 2 times 2 is 16. And then I have y to the third to the fourth. And again, a power to a power, we multiply those exponents. Still not done because we can clean this up. 27 times 16 can be cleaned up. And if we work this relatively quickly, hopefully, we'll see how my multiplication skills are. When we add that up, we should hopefully get 432. And so I have 432 x to the 6th, y to the 12th when I clean up that original expression using the properties of exponents. One last very quick example just to show you a way that I might make you apply this on a quiz or on an assignment. If I ask you to find the area, we know the area of a rectangle is the base times the height. In this case, clearly, one side is 2x inches long, the other is 5x inches long. If I take 5x times 2x, I notice I multiply those coefficients and I get 10, and I have an x times an x, which would be x squared. And then as we've seen on quizzes and tests in the past, labels matter. Area would be inches squared. Very quick run through for the powers and rules of exponents. I strongly recommend you maybe rewind it and watch the parts where we went a little fast, double check and make sure you like it, and have this video watched and have notes prepared for this by Monday.